Let's talk about rational expressions. In this video, we'll be multiplying, dividing, adding, and subtracting rational expressions. And I'm not going to simplify too much as I go, just to get the major points across. Okay, so my first example here is multiplying two rational expressions. They're rationals because they're polynomial over polynomial. And multiplying them is the smoothest of these four processes. So we can just multiply straight across the top and straight across the bottom. The one thing I'll point out is when these rationals are alone, they don't need parentheses anywhere. But if they're going to combine with each other, there's a secret set of parentheses that are going to be grouping any numerators or denominators that have multiple terms, meaning like they have an addition or subtraction in there. All right, so x times 5 is 5x. And then on the bottom, you could either FOIL this out or just keep it as is. Like I said, I won't FOIL stuff out in this video, so I'll just leave my answer in that form. Dividing two rational function or expressions is almost just as straightforward. So dividing by a fraction is multiplying by its reciprocal, which is that fraction upside down. That's true for fractions, and it's true for rationals as well. So this would be x over x plus 3 times the reciprocal of the second one. So I'll have x minus 1 over 5. Now that it's turned into multiplication, I can do my implied set of parentheses and just multiply straight across the top and straight across the bottom. You can also put this 5 on the left side of the x plus 3 if that makes your eyes happier. So we have to do a lot more work in combining rational expressions when we're adding or subtracting them. So multiplying and dividing, we're going across the top. Here, we can't add or subtract fractions that don't have the same denominator. So we have to, every single time, make a least common denominator before we combine them. So we'll start with this example here, x over x plus 3, now plus 5 over x plus or minus 1. So these denominators have nothing in common. They're just their own little factors. So my least common denominator is just the product of the two. So it's the x plus 3 denominator times the x minus 1 denominator. And that's my LCD because each of these fractions can be multiplied up to get there. This one needs times x minus 1 over x minus 1. This one needs times x plus 3 on the top and bottom instead. So I'll put in this multiplication. I'm going to do this in red so it stands out. So I need to multiply this by x minus 1 on the bottom so that it has the desired denominator. And then to balance that out and keep this fraction equivalent to what it started as, I have to put that on the top as well. And then we'll do the opposite on the second expression. So the x minus 1 needs an x plus 3 multiplied on to have our desired denominator. And then to balance that out, we'll put another one up on top. Now that these fractions have the same exact denominator, I can add across the top and then keep that denominator. So on the top, I have x times x minus 1 plus 5 times x plus 3 over the common denominator. And I can have these two factors in either order, doesn't matter. And again, I'm going to stop here and not do any elaborate simplifying. If you wanted to keep going, you would distribute this x into the parentheses, same with the 5, and then combine any like terms. All right, so in general, in the simpler cases, the least common denominator is just the product of the two denominators present like we saw here. That's kind of the default position. There are some interesting cases though, where the least common denominator is a little bit less than that. And that's what my next two examples are going to show. So in this one, my denominators are x plus 3x plus 2, and then x plus 3x minus 4. So they both already have x plus 3 in them. So we don't need to have it there twice. My least common denominator can be x plus 3, x plus 2, x minus 4. So then this one just needs times x minus 4, and this one just needs times x plus 2, right? So I don't have two of these present, making things even bigger. Right, so this first fraction needs x minus 4 top and bottom. And then the second one is missing the x plus 2, and again, it has to be top and bottom. Now that the denominators match, I'm free to just subtract across the top and keep my common denominator. Okay, one more example to look at kind of a weirder case of least common denominator. This is my last example here. So this one is extra annoying because these denominators are not already factored the way that these were. And we really need to see them factored to know what the LCD would be. Like, we have no idea what needs to be multiplied to anything. So my first step before I do anything is going to be to just factor each denominator. So this one here, I can take an x out. And then x squared minus 4x plus 4 is x minus 2, x minus 2, which I can write as x minus 2 squared. This second one, I can pull out an x, and I get x times x minus 2. So these denominators, now that we're seeing their factored forms, actually have a lot in common, right? They both have an x, and they both have an x minus 2. This one just has an extra. So my least common denominator in this case is the first denominator. Right, so this one doesn't need any multiplying, it's just ready to go. This one just needs times an extra x minus 2, top and bottom, to have this as its denominator. So that's what I'll do. I'll have x minus 2, and then another x minus 2 here, which makes it x minus 2 squared. I can add across the top. I can use either the factored form of that denominator or the unfactored form, which is this original denominator here. And again, if we don't simplify, we are done with the problem.